Hello interwebs, welcome to Let's Fix Computers. In the previous video I showed you this CH341a mini programmer and we were doing a voltage modification on it to fix the high voltage that it puts to the chip. I say high voltage, by default it was putting 5 volts out to the data lines of the chip, which is too high. It should be at 3.3 volts, but due to a design flaw it actually sends 5 volts to the data line. Now, for those of you who weren't quite sure what the problem was there, the way that serial communications work is a lot like using a signaling light. If you're trying to signal a ship out at sea with a very bright light, you shine your light out to the ship and the person on the ship will see the bright light and know that someone is trying to communicate with them. That's why the line is pulled up to a high voltage by default, or a high signal. And then to communicate, you'd cover the light with your hand in a series of pulses, and the person would watch those pulses and see the line going low and high again and know that there is communication happening. But the problem is, imagine that instead of having a nice torch, you've actually got a hurricane lantern. Every time you put your hand in front of it, it burns your hand. That's what was going on here. The light was way too bright and way too hot for the communications it's doing. And you can get away with it, but it's not good for your hand. So that was the problem with this thing and why we needed to modify it before we used it. So with that in mind, the first thing I'm going to do is show you what kind of problems we can fix with these things, and I'll demonstrate how we fix them. So before we reprogram a BIOS chip, we need something that needs reprogramming. Now, I could test this just on a working board and I could flash it up and down a couple of versions just to demonstrate the fact that it works. But I think what might be more effective is to show you how these things can be used in the real world and in real life. So I've got here one of my demo computers. This is got a Ryzen 3600 in it, and it's an MSI X470 Gaming Plus Max motherboard. And at the moment, I'm in the middle of updating it to the latest BIOS. So we're in M-Flash here. We're at 21% of a BIOS flash. And you know what would be awful is if there was suddenly a power cut. Don't try this at home, by the way. This is a stunt. So, the power went out by some terrible twist of fate. And when you plug in your computer in the midst of a panic and go, oh no, oh no, oh no, and you turn it back on again, and you watch the diagnostic LEDs and hope. And all you can see is those diagnostic LEDs flashing as it boot loops. So this is now a bricked motherboard. Now if you had a higher end motherboard that has BIOS Flashback, this would be the point where you'd use BIOS Flashback to save this from a bricked state. Because BIOS Flashback allows you to, the motherboard literally has an onboard programmer that can reprogram its own BIOS from a state like this, from a complete no-post, completely scrambled BIOS condition. However, not all motherboards have this. For a moment, it looks like with B550 and X570, it was going to be pretty much standard on all motherboards. But you'd be surprised, there's still a lot of mid-range and up motherboards that don't have it. So now we've got a motherboard with a completely scrambled BIOS and no way of recovering it. Okay, so we need to get the motherboard out of this computer now and get access to the BIOS chip. So I'm going to strip this thing out and we'll go from there. So here's our BIOS chip that's tucked away underneath the M.2 drive above the first PCI Express slot. Now there's a couple of ways that we can connect to this chip. The first way is using this jumper here, sometimes known as the JTAG connector. And this connector here, the pin out on it will go directly into the BIOS circuit. So theoretically we could plug in a ribbon cable and interface straight into the chip. And that would then connect up to our mini programmer. Unfortunately, I don't have that cable, so we're not going to use that method. The next method is that we could clip onto the chip using what's known as a clip, which is this guy here. So it's a little grabby hand, and then that goes to this DIN adapter, which would plug into our mini programmer. So the idea is that this guy would clip over the top of the chip. Now, this is a cheap Chinese one, and I've never had any luck with this guy. Every time I do a video about BIOS programming, I get people in the comments who swear by these things, and usually it's because they've either got a lucky roll of the dice and they've got a good one, or B, they've got a very fancy one that was also quite expensive. Now, if you're one of those people who's got a fancy expensive one, please let me know in the comments which one you've got, because I want to show people a decent clip in action to prove that they are a viable strategy. Just I had no idea which one to buy that would actually be reliable. So let me know what you think about that. So that's the clip. The last method, which is what I'm going to do today, is to physically desolder the chip from the board. Now, this sounds like fairly drastic action, but it's actually very easy to do as long as you have a hot air station. And a hot air station, I know not everyone has them lying around, but if you're getting into tinkering and repair, worth every penny. Absolutely get a hold of one. Even a basic hot air station will be able to take a chip like this off of the board. You don't have to buy a super expensive one for doing really detailed work. Just a basic one will help you get big chips off of the board like this. So I'm going to switch on my quick 857 DW+, and I'm going to desolder that chip from the board. So our BIOS chip that we've now removed from the motherboard is an MXIC and is an MX25U25673GZ. Now, at this point, I would be saying, now let's go find the datasheet for this to determine what voltage this chip is. However, I actually couldn't find a datasheet for this chip. And if I'd known that in advance, I'd have picked a different computer to do this demonstration with. Because in an ideal world, we should be checking the datasheet to see what voltage this chip is in order to determine what adapters we may need to use with our mini programmer. But I'm already committed to this one, so we're going to roll with the punches. So there are a couple of cues that I can use to determine what voltage this will be. The first thing is that it's a WSON 8 chip, and that is the type of size package this is. As you can see, it's a very flat surface mount chip that is very thin and very flat. Now, that is not a guarantee that it's a 1.8 volt chip. MacBooks, for example, have WSON EFI chips in them that are 3.3 volts. However, most of the time on desktop motherboards, if you see a WSON chip like this, it's probably going to be 1.8. The other giveaway that we have is that it's a 25U256, and that U, I believe, designates that it's a low power chip, a la 1.8 volts, whereas if it was a 25Q or 25L chip, that I believe would signify that it's a 3.3 volt chip. So again, take this with a pinch of salt. You should be looking up the datasheet. I've just been caught out by this particular one that I chose to do my demonstration with. So the important factor is that we have a 1.8 volt chip. Now you might say to yourself, hold on a minute, didn't you just mod your CH341a for 3.3 volts? Yes, I did. And this should be a 3.3 volt programmer. And my usual weapon of choice, which is my RT809F, this is also a 3.3 volt programmer. In order to program 1.8 volt chips with these, we need to use a 1.8 volt adapter, which is this guy here. And this guy, as you can see, has got these pins on the bottom that drop into the socket of the programmer. And then that gives us a 1.8 volt adapted output that we can then put our chip into. And we are going to use one of these with the CH341a today. If you want to avoid using these voltage adapters, you need to get a programmer that doesn't need one. And there are ones out there, such as that one particular model that I've forgotten the name of, but it will be on the screen now and I'll put it in editing. But for most people, I would ideally make sure you have one of these in your arsenal. This is one of the reasons why it's never simple doing BIOS chip programming. There's so many little pitfalls and things to watch out for. But again, hopefully by showing you these videos, you can get an idea of what bits are out there and what bits you need. So that solves our voltage issue. But how do we get this chip into one of these sockets? So there's a couple of ways to do this. The CH341A does actually have SMD pads on the bottom for connecting up most chips. So if you're a mad lad, you could actually solder the chip directly to the bottom of the programmer. But that's not going to work for us because we won't get the 1.8 volt adapter in between. So we can't use that for this demonstration. So instead, I'm going to use this WSON8 adapter board that I have. And again, all of these parts are really cheap on eBay. And I'm going to solder this chip onto this board, which then gives me a pin layout that I can plug into my adapters. So let's solder that onto there. People often ask me what airflow to use. That's your answer. If you're blowing things away, you use less. It's like, how hard do you push the brake pedal on your car? As much as you need to. My God, there we go. It's straight. Right, now we can build up our confusing sandwich. So I shall take this and I will put pin 1 in the top right, and that goes into our adapter. So pin 1 goes to pin 1 as indicated on the board. And then on the bottom of the programmer, it designates that for 25 SPI BIOS chips, we put it this way around with pin 1 in the top right. Notice the little half moon halfway up there. Then if you've got a 24 series EEPROM, then that goes on this side. So that means that we need to put our adapter pins, pin 1, over here. There we go. And there's our complete stack. If it looks jank, it's because it is. However, that's literally how you do this. Tell me about it. You can see why a lot of people like to use clips, and also why I want to have a working clip system. I don't mind doing this, but it's very difficult for me to make a video like this with a straight face and expect the average person to do this. Conveniently, the article that I was referencing last week to do the 3.3 volt mod on this device also has a list of the drivers and tools for it. So the two that we need are the CH341ser.exe and par.exe installers, which include the USB to serial driver and the programmer driver. So you need to download both of these items, all of which will be linked in the description down below. And then you also need some software to actually do the programming with. And previously, when I've already used this programmer, I used the same one they're recommending, which is AsProgrammer, and that works just fine for me. So get those installed on your computer, and then we can actually start using this device. Anyway, here's my laptop with AsProgrammer running, so we'll plug this whole affair into the side of it. Hope it doesn't blow up. And now let's go ahead and see if we can identify the chip. So the version of AsProgrammer that was linked on onetransistor.eu is the same version that I already had downloaded from elsewhere that a friend had sent me, which is version 141. And unfortunately, that didn't actually support the chip that we're trying to program either. So my misfortune of having picked one of the most awkward chips imaginable to do a demonstration with continued. But I did some digging and discovered a version 2.1. Now, I downloaded this from a pretty dodgy looking Google Drive link. Now, I will rehost this just so it's coming from potentially a slightly less dodgy Google Drive download link, but make of that what you will. In any case, if anyone knows a better source for AsProgrammer or has some tips on some other software that works with the CH341A, let me know, because I would like to find some better alternatives or just something that's a little less ropey. However, we have some software that I know supports the chip. So I'm now going to rig everything back up again. So I'll drop my stack back together, and in the IC search, I'm going to search for MX25U256. And here we have the MSI 25U25673G, which is what we want. Select IC. Now, fun fact, my RT809F didn't actually recognize this chip either. It's possible that there's newer software available for that programmer that would have done it, but this is one of the pitfalls of doing programming like this and using cheaper programmers, is it's a matter of chip support. If you don't have the support for the chip you need to program, you're crap out of luck, basically. So yeah, I wanted this video to be possibly the simplest demonstration of BIOS reprogramming that I could manage, but unfortunately all I seem to have done is just illustrated the fact that there are many, many pitfalls in doing this, and anyone who says otherwise is just experienced enough to just gloss over all of them. Make of that what you will. In any case, we're ready to program our chip. So I'll try and do a read on the IC. However, I'm 99% certain that this thing is completely scrambled. So let's see what we get from it. Reading memory. So we've got the operation light, the run light on the device on now. So we know it's working and we have a progress bar. So I'll let this read. However, like I say, I'm 99% certain that we're not going to get anything useful out of this chip. This is just showing that we can actually read it. Also, just in case anyone is wondering who watched the previous video of doing the 3.3 volt mod on this, I can confirm that these 1.8 volt adapters, they do cut down the pull-up voltage to the data lines as well. I've just checked that using a multimeter just to make sure, because I'm sure someone would have asked if I hadn't mentioned it. Hey, look at that, we did actually get some data. However, like I mentioned, this is going to be scrambled garbage. There might be some stuff there, however, I think most of it is going to be trash. So what we'll do now is we're going to open a file. So I'm going to open our file to write. I'll select any file, and you can see here I've got the downloaded BIOS that I got from the MSI website for this motherboard. So we'll open that, and now we're seeing that is the data we want to write. So we've opened that up. And now I want to write that to the chip. So what options have we got here? Let's just do a write, I guess, and I'll see what it does automatically. Program IC, go. Start programming. Normally I would have saved the contents of the chip first, just so we have a backup of whatever was on there. However, I don't actually care about whatever was on there because we know it's going to be a garbled mess, because this has had several failed programming attempts on it now. However, if you are modding, or if you're trying to mod the BIOS or tweak parameters in it or do something weird like that, you would absolutely want to make sure that you've saved the current state of it first. Alright, and we are success. Now, I haven't seen it try to do a verify. Normally when you're programming chips like this, you would do an erase, write, verify cycle. We don't seem to have gotten that. If anything, I feel like I probably should have tried to erase it first. But what I'll do is I'll do a verify, which is probably this button here. Here we go, verify IC. Verification on error. Oh, well, there you go, straight away. That suggests that the contents of the chip doesn't match the file we loaded. So let's run that again. Let's erase the chip and then program it a second time. Alright, chip has been erased, so if we now do a read from the chip again, so read IC, we now should find that it comes back actually empty. These reads take quite a long time on these chips because these 256 megabit chips are huge. I think that's one of the reasons why this is a bit of an obscure chip, because these abnormally large chips are a response to AMD motherboards that need horrendously huge BIOSes because of the number of CPUs they support. This was a problem that AMD have had during the AM4 era, which is one of the reasons why AM4 has to die and AM5 needs to come in, because there's just simply far too many CPUs on that socket now. Right, so now we've done an erase. The chip is now empty. We've got all Fs everywhere. So let's try programming again. So I'm going to reopen my BIOS file. And once again, we're going to program IC. Start programming. Programming success. Let's try another verify. Okay, got further this time. Let's let it run. This takes ages, man. I wonder if the really expensive programs can do this any quicker, or whether it's just these big old 256 megabit chips. Verification complete. So this clearly shows the importance of making sure that A, you verify the chip after you've programmed it, and B, you erase it before you program it. Most software would have an auto mode where, as I say, it will erase, program, verify all in one go for you. Looks like AsProgrammer doesn't have that. Either that or the function is hidden away somewhere. But that's not the end of the world. We can easily do it with the shortcut buttons along the top. So now we've programmed our chip, we've just got to put it back on the board and our motherboard should light up again. Both the camera and the fan are in my way right now. I should move them, but I'm going to be a little bit lazy here. And a little bit of cleanup with some alcohol, just to deal with that big old splat of flux I just put everywhere. Now let's set this thing back up on the bench just to see if we've got it working, just before I go to the trouble of putting it all back into the case. I've got faith in this, however, this board has been through a lot today. Okay, power on. So the LEDs we're looking out for are up here. Those are our diagnostic LEDs, and we want to see those cycle through to the boot screen. Then we should get a picture out from this. Cycled over to VGA and then boot. Look at that, first time. Beautiful. And that's one fixed board, everyone. And just for good measure as well, you'll notice from the BIOS version that we're on the latest BIOS as well, because that was the latest one I downloaded from the MSI website. So there we go. I'll put this in the computer now and we'll have this thing up and running. And there you have it, folks. It lives again. So this computer is now fixed, and we've gone from being completely bricked to entirely recovered to the latest BIOS. So now let's close up on my final thoughts about the CH341a and whether or not I think it's a good product. So I've featured a couple of different SPI serial flash programmers now on this channel, including this one, the RT809F, and also the original EZP 2019 that I used to recover a Gigabyte B450 Aorus motherboard that I'd gotten into a bit of a twist with as well. And there's various people that have said sort of, oh, I've bought one of these, or I've bought this one. Do you now recommend that I should buy this one instead? Well, they've all got their strengths and weaknesses, to be honest. The CH341a, it's incredibly cheap, which is what makes it a very attractive prospect. It's very cheap and it's a very simple looking device. You look at this, there's no cables to it, you just plug it straight into your laptop and you're off to the races. And also because it's open source and people have reverse engineered it, there's a lot of information about this guy out there. That makes it a very attractive prospect. But the other thing as well is that you do have to go hunting to find the latest software. There's no official support available for this thing. And you're going to need various adapters depending on what you're doing with it. And if you want to use it at all, ideally you need to do the 3.3 volt mod on it as well. So it's difficult to say that this is a good product per se. Likewise, the 809F is not perfect because this also requires a 1.8 volt adapter for 1.8 volt chips. So would the 2019. Now when I bought this one, I bought it for cheap. I think I spent like £20, maybe £25 on this thing. And it came with a whole bunch of adapters and clips and other oddballs, which is why I have a selection of accessories. So even though this is my last choice in the programmers I have available to me now, I still don't regret buying it because A, it showed me what the cheapest of the cheap looks like, and B, I've got a bunch of useful accessories with it that I can mix and match to find a setup that works. So the question is, if you're looking for professional equipment to do a job with, if you're setting up to do BIOS recoveries on laptop motherboards and stuff like that, this probably isn't the guy that I would purchase. I would go and I would buy an 809F, an RT809F, or to be honest, probably the TL8662 Plus, which is considered to be the daddy of all of these programmers. That's the one that everyone says this is the last word in programmers for repair. However, if you're a tinkerer, and right now I class myself as a tinkerer in this, in that I'm not necessarily offering this as a mainline service, this is just something I do as well on the side. I'm learning about programming and I want to try different programmers so I can understand them better and understand which ones are better than others and for what reason. To that extent, buying this to play with and doing the modifications on it and trying the different software on it is fantastic for learning. I learned a lot about this programmer just by making this video, which, as I say, got close. It was this close to getting thrown out several times because I thought I was at a position where I'm just like, this isn't working out. You know, I can save this motherboard, but I need to use a different tool, or I need to fall back to my 809F or something like that. But I ended up managing to do all of it with this guy in the end. Although, granted, I already had the 1.8 volt adapter. It's up to you whether that was cheating or not. So, if you're tinkering in repair and you want to spend as little as possible, or you want to have a big selection of toys to play with and tinker with, then the CH341a is a great place to start. And also, if you already have one of these and you're not really sure how to use it, then hopefully I think this video might have been a really good insight into the ins and outs of it. However, if you're going into business and you want to buy a professional programmer that will not let you down and will work with everything, this probably isn't the best solution to that. I said while I was recording this that may or may not be in the final cut earlier on that this video was intended to be the simplest demonstration of recovering a bricked motherboard, and I don't think there was anything simple about this, to be honest, but I hope that at least it was informative. So on that note, thank you very much for watching, and if you liked the video, don't forget to hit the like button because it tells YouTube that this is the kind of content you want to see. As always, my support links are down in the description below for my Patreon, my Discord, my Twitter and my Instagram, and I'll see you in the next video. Thanks a lot and goodbye.